Great. Hey, everyone. Thanks for being out there. Thanks for adjusting to the time. It's just me tonight. Joe and his lovely wife are enjoying a little time off. Good for them. I'm going to bring you up to speed with where they are. We've made some progress in our learning of Docker and Kubernetes. Very exciting. And maybe we'll get something resolved today. Once again, this is my first time ever pushing all the buttons and being in charge of things. Apologize for Tuesday. Didn't have all the right accesses. Looks like we've got it sorted out now. If you see me madly clicking around, it's because things are happening and I don't quite understand why. So all right. Just a recap of where we are trying to take one of Joe's example apps that he made in a previous live stream and put it into Kubernetes. The first step there for us was to Dockerize it, run it on our local machines in Docker. There's two reasons for this. First of all, you use Docker to build containers for Kubernetes. Docker's one of the things you can use. It's probably the most common out there. It's also very well documented, very well supported. So that was part of the reason. The other part of the reason is if we get it in Docker and can make it run in Docker, then we have the ability to debug this when we try to go to Kubernetes. And that's where we ran into some problems. We could run the app or we could run the UI and the API just fine on our local machines as a normal Kestrel install. It worked great. We could Dockerize the two different pieces, the API and the web UI, individually run them. Couldn't make the web UI call the API. Took us more than I want to admit to figure some of these things out. We could, however, run the API in a container, run the web UI on the local machine, the host machine, and call the API like that. So it's something really weird in between the containers. And the good news is we figured that out, but we also then got right into another problem naturally. At first, Joe was really sure that the problem was solely HTTPS and working developer certificates. There are known issues, but we had some of our own. So let's throw up a screen share here. We'll walk through some of this stuff. Share the screen. Okay. Share screen. Select. Which one's which? Is this it? One. Ah, rock on. Okay. Got it. Cool. So we are good. We're in Visual Studio. Rock on. So once again, I have three monitors going, so I've got to join Hanselman's big cursor gang to keep track of my cursor. So we where were we? Oh yeah. So we made some changes and figured a few things out. So one of the fixes that I came up with is kind of embarrassing, but it's one of those things that just drives you crazy after quite a lot of time, and it's the infamous typo. Uh, Joe had changed this line of code. Before in the configuration, the app settings, we put the local URI, contacts, and a slash. He took the contacts and just put that here. So we only have to change the port and not worry about this contacts. He forgot the slash right there. And that was part of the problem. We got that working, and that led us to another issue. I got to back up. Uh, Before I could get to that issue, we couldn't even get the web UI to call the API. And it turns out there is a trick when you're trying to do this between two containers running in Docker Desktop on Windows. And that trick is the loopback URL that you need to use in your when you're addressing a container, one container from the other. And it reads like this. Instead of using localhost or an IP address, you use host.docker.internal and the port that's mapped to the host. And once I did this, the web UI was able to call the API. Great, but it threw that error that indicated, okay, the next problem is contacts wasn't the right suffix. So I fixed that. Great. Once I had that done, I was able to throw another error, and that was related to HTTPS and the use of developer SSL certificates in containers, especially Linux containers running on desktop. So this has been quite an adventure. So what I ended up doing was editing these files, and I will bring those up really quick. Here we go. I edited files to take out the HTTPS configuration, and I can show you where that was done. One was here in Docker file. No, don't want to commit it. We want to diff it. One was here in Docker file, and I'm just using Tortoise Git, one of my favorite little UIs for Git. If you remember Tortoise SVN, this is the successor to that in the Git world. Tortoise SVN is still rocking out there in the Subversion world. Okay, so all I did was comment out in the Docker file to not expose port 443, and in the where was it? Properties here, I think it was launch settings. Yep. Yes. We set use SSL to false. The right side is showing you what we did. Set use SSL to false, and we took out the port mapping for 443. By default, .NET code has gotten more and more secure, and if you expose any part of port 443, it's going to try and ram everything through there. This actually took me a couple of tries to figure out. The upshot is, uh, drum roll, if you're hanging around out there, that I can now run the API in a Docker container and then run the web UI and call the API. Some other time we will go down the adventurous rabbit hole of running or of using developer certificates in containers on Docker desktop on Windows. It's apparently quite a bit of stuff. And my kids are back in school, so we've got to like get our evenings back. Some of these nights we'll have to figure out what night we're going to do this. Okay, the API is booting up, running somewhere. Don't know where. There it is. Drag this window down here. Oh, wrong way. Lost the window. There it is. Cool. And this should populate with some fake contacts from Joe's previous thing, which is great. Here we go. Nice. All right, rock on. So that's the API running in a Docker container. Let's flip over here. We will start the web UI, run that in a Docker container, and things are coming along. Building, building, building. And here we go. The output. Fool. Forgot to do something. Wrong one. Got to build the web UI. While that's building, something interesting that I don't know if I'll be able to show, but we might have to switch back and get some other get the output window is, yeah, there it is. Problem loading the page, right? Go to advanced. We'll accept the risk and continue here on our local machine. This is the web UI running under TLS. That's fine. If we hit contacts, if I haven't messed anything up in the last hour, oh, 32778, the IP changed, or the port changed. Random mapping for the loss. There's a way to fix this. We'll figure that out another time. Okay, cool. This should turn up fairly quickly. And let's see what we've got here. Building, building, building. Very good. Whoop. And here we go. Takes a moment to build. Okay, rock on. 32779. Great. Contacts viewer should be. Ta-da! Finally, all this time, we got the two Docker containers talking to each other. Admittedly, you'd want to probably secure the conversation between containers, especially if your clusters are going to run anywhere close to the public internet zone. Um, we'll figure that out another time. The three steps of software engineering, right? Is first make it work, then make it work better, and then make it look good. We're in the first make it work step right now. We will make it better as we go along. So, cool beans. If you ever get stuck trying to get two containers to talk to each other, just remember this setting right here, host.docker.internal. I don't know where it's documented. I found that in a Stack Overflow answer. I tried to find that in official Docker documentation. I didn't see it, but we'll keep looking. So I did test this earlier today. I pulled out all the SSL, made it work with that loopback URL, and I thought, aha, maybe that's just the problem. Put all the SSL back in. Nope, through certificate errors. That's okay. We'll come back another and figure that out. So that's good. At least we know we can run this stuff in Docker and all things are good. So we'll stop these containers here because we don't need a ton of stuff running while we go on to our next step, which is trying to get this stuff to run in Kubernetes. And where's my mouse cursor? Come back. There we go. Stop this one too. So is that okay? Rock on. Good deal. We're in good shape. Those two should be stopping any moment now. No, Minikube should be running. Okay, cool. So here we go. On to our next challenge. Like I said, I've been playing around with this, so Minikube should still be running. Let's see if that works. Yep, okay, good. Minikube is running as the control plane. Rock on. So we should be able to do Minikube dashboard, and we will see here. Bring this down again. Where'd it go? There it is. Come here, big mouse cursor. There we go. Wrong way. So good. As you can see, all my circles are green. That's good. Like I said, I was messing around with this earlier. I have pods running. I have services running. We'll get into the debugging, but let me show you because Joe and I had some trouble last time getting the circles to be red or getting the circles to be green on his machine. So let me show you some of the stuff that we did here. First of all, cube control. One of our friends used to call this cube cuddle, apparently, and now I mistype that all the time as CDL. So the nodes I have running are just Minikube on the local machine. Okay, and should only have one node on my machine, right? It's just a single machine. So we'll go cube. Typing is not my strong suit. Cube cuddle. Neither is typing like wisecrack jokes. Get pod. All right. I have two pods running. I have the contacts API pod and the Hello Minikube. That's fine. We'll replace that contacts API pod in a moment as I show how to build this out. And let's see what else we have. We have cube, cuddle, get service running. Let's check the services we have running. Okay, great. We have the API local service, which should be routed through to the contacts API pod based on configuration, and that will work. So, interestingly, the way that Kubernetes works on your local machine is it basically runs a little VLAN on your machine that the node is basically VLAN and there's the pods inside of that. There's no direct access to the pods without some other service. This service can basically, at its simplest, a TCP listener for different protocols. Here, this service is just going to be basically a proxy that's going to pass through our HTTP requests straight through to the API that we have running. I'm going to make the API run first, hopefully, and if not, we'll try and debug that. So cool. I can delete this stuff. We can do a little cleanup and we can build some fresh services. Hopefully hasn't changed a whole lot. So we can do cube, cuddle, delete. service, API local, and then we delete pod, right? Pod, contacts, a contacts API dash pod. All right, rock on. And this should delete. Great. So all my fooling around from earlier is now cleaned up. Um, so we're going to leave everything as it is. And I'm going to scroll down on my cheat sheet up here. Um, the way that we're going to do this is I'm going to copy this because I don't like typing this twice. Cool. So like I said earlier, in Kubernetes, you build your image with, or one of your options for building your image is in Docker. It's practically the de facto default, at least as far as .NET and Windows developers are concerned. So we're going to use that. The command, we simply drop into Docker. We say image build. We give it the file name for the Docker file. I'm probably in the wrong, oh, I'm definitely in the wrong folder. Hang on. Backslash K8 intro. That would have failed. Source. Okay, cool. Great. And now this will work better. Um, you give it the file name of the Docker file, which is our contacts API Docker file, and we give it a tag. The tag right here indicates where this is going to be published. So the tag says account or main tag, path, whatever. RJ Dudley, that's me. Contacts API becomes the repository, and the last is the actual tag that we want it to have. So it's account slash repository slash tagged build. I already have a 1.0 out there. So let's give this a 2.0. There's been no changes, but I just want to show that happening. And at the very end, there's a dot, which means work from this current folder. Um, Kind of weird the way I have it. You know, I have the contacts API. I'm working in the parent folder. You can change your folder input later if you want to. This just has worked for me several times. Don't forget the dot or the final parameter. If you do, you'll get this crazy thing. Docker build X requires exactly one argument. If you come out here and put a dot, Docker build X is happy. So now it's building a container of the API that we just saw running in Docker, um, preparing it with the right account and repository to publish, and giving it a tag of 2.0. The steps are interesting. You know, it loads the definition, looks at the Docker ignore, yada, 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 gets all the metadata, sees that, yeah, these are current, should be because I just used them earlier. Work from the cache, da da da, run the build. So here's MS build running now. This is pretty groovy. Takes a moment. Okay, building the domain, building our data contexts, putting in the business logic layer. I would have done this in probably half as many projects, but that's me. SQL Server, SQLite, and yeah, cool. So there we go. We have built our container, and now we can publish it. There's a couple ways to do that. Sorry, two-step build. My bad. If I had musical talent like, I don't know, Forrest Brazil or Cloud Bart, who sadly passed away recently, I'd play some music for you all, but I don't have that ability. So I'll just stand here and do my best to look attractive. We'll see how well that goes. Again, building, publishing, cool beans. Now we're done. So this has been named, and we can now it registers your project. Let's push it. We just simply do Docker image. Whoops. Now The difference between what I did and what Joe was doing last week, Joe was trying to run everything off of local cache. I finally said, heck with that. A Hucker Hub has a nice little account where you can push your junk for free. I'm going to use the free tier for a little bit and see if it works better. And it seemed to because I have green circles. So we're going to push this out to Docker Hub. If you're following along, you can probably head out there and find my junk. It is pure speculative junk. Where are we? Oh, yeah, Docker image push. Give it the account, contacts, API, and we're going 2.0 this time. Oh, no, we're not. Now we're going 2.0. There we go. Um, so something really interesting about the internals of Docker is so if you see this, layer already exists, yada, 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 yada. When we talk about containers, we talk about them as if it's a single thing, like a virtual machine, like you can just pick up that VM and move it to another host or whatever. It doesn't really work like that. Containers are more of a virtual construct that is assembled at runtime from a number of different layers. And so everything that you do to modify the file system, everything you build, you install, whatever, creates a different layer. And another reason why containers are so efficient is these layers can be shared between images and containers. And so I had done a API build a couple hours ago labeled with or tagged with 1.0. I'd made no code changes since then. So every single layer already existed and it doesn't really have to push anything. It just has to register a new build number with a new tag. Um, and so it's not taking up any more space than it was earlier. And that will happen both on your local machine as well as when you push it out to Docker Hub. The cool thing is that some of these layers are the same between our API and our web UI. And so Docker is smart enough to go, oh, okay, so this base image, great. I'm just going to use this layer that's there. And then it manifests that um, final container image at the very end when you run the thing. So that's another little bit of trivia about why Docker and containers are so super efficient is layers and the way that they can be shared between images. So which is cool. All right, so that should be out there. Let's take a visit to Docker Hub since we've mentioned that it's pretty gnarly and free. As soon as I can grab a window and come down here, we can go to hub.docker.com. Oh, yes, welcome back. Hello, hello. I'll sign in. Please work, please work. Don't make me remember my password. Thank you, Docker, for having a greater than 24-hour token on that. So here we go. That's my account, RJ Dudley. That's me, repository, contacts API. We should have a couple images in here um, that are tagged. We have a 1.0. Let it catch up. We have a 1.0 a couple days ago that I was working with, and we have one that we just pushed about 3 minutes ago. So that's great. Again, they are running on Linux, and it's an AMD 64 architecture is our build. So very cool in today's technology how this all comes together. So that's my Docker Hub. It's I think public. If anybody wants to pull it down, whatever. Good luck with the API. There's nothing super secret in there. All right, let's drop this. Let's drop this. So, a couple things to look at now. These files that we're going to check out live outside. Oh, let me get in here. Okay, a couple files that we're going to look at pod.yaml and service.yaml. So, Joe was working with these the other day. Interestingly, these live outside of your Visual Studio. Get out of my way. Uh, what did I do? Oh, no, go away. These live outside of a Visual Studio solution, so they don't show up, and that's fine. They're also at a level above where this stuff works. So we can either open up with VS Code and open the folder, which we'll do, and hope we don't cripple my system here. And let's open a different folder. This QSK book, this is the Quick Start Kubernetes book that I was working through to test the installation and setup, and it worked. I followed their instructions, and I was able to confirm that my setup was working. So that feels good. It's pretty easy just to double click install, but whatever. All right, let's go into K8 intro. We'll open this folder. I like VS Code because it has all kinds of cool extensions and editors that you can plug in there. It does handle YAML fairly well with the IntelliSense, not the IntelliSense, but the highlighting and stuff like that. So first thing we want to look at is the pod file. So the pod file directs Kubernetes, in this case Minikube, how to build out the pod on Kubernetes. The V1 refers to the version of this file. I don't know if there's a V2 yet. I haven't gotten that far. We're building a pod is the kind, is the instruction. The metadata is the name contacts API pod. And you remember earlier when I went back through and saw what was running, the name was contacts API pod. That's where this comes from. And the project is tagged K intro. That is a free form tag. I give it the same name as the project. I could have just put Great Googly Moogly or John Jacob Jingleheimer Schmidt or whatever I wanted to in there. It's free form, but I'm a simple man. I name things for what. Um, we're going to use one container. We're going to call that container contacts API, and we're going to change this because we just pushed the 2.0. And this says the image is RJW Contacts API 2.0. That's the one that we just pushed up to Docker Hub not too long ago. Oh, and I got to change the container port here, right? Yep. So we should change that to 80. Cool beans. So missed something in all of my fooling around earlier. That could be why stuff wasn't working, and I may have just solved the problem. We'll see. What this is going to instruct Kubernetes to do is pull this image and build it into a pod and run that pod. So we can flip over to the command line real quick, and we will do kubectl. Again, this is like a nothing up my sleeve Bullwinkle move here. Get pod. Um, the only one we have is the Hello Minikube pod running. That's great. That's your background service. And now to build the pod, we simply say kubectl. I think we're going to have everybody calling it kubectl after this. And I'm going to have to alias that CDL with CTL because I type that wrong all the time now. So we do kubectl apply -f flag means the input file, pod.yaml. So you can name these YAML files whatever the heck you want. Nothing big, nothing, it doesn't matter. There is sort of a naming convention about naming like pods pod and services services and so on and so forth. So that should build out our pod, should be fairly quick. Cool. The reason that was so quick is because it found that thing in our local cache. Add them. No, not now. Don't update anything. Where's my terminal? There it is. So cool beans. So now we can go through and get the pod, and we have our contacts API pod running. Okay, that's awesome. However, we can't get there because we don't have the service. In this case, the proxy service. It could very well be whatever you want to put in front of this thing. Could be probably WinSock or one of those other SSH, FTP, whatever you want to put out there. So let's look at the service that we're going to put out here. Again, we're telling it in the instructions what kind to build, and we're building a service. The name is just going to be API local. Great. The type is node port. That's just a thing to do internally. That's what you run in your local machine. When you go out to real Kubernetes, you'll use something like an ingress service, which puts a little bit more oomph around your HTTP direction. We're going to expose ports 80. We're going to give it the node port of 32767. That is the fixed port that should be there. The target port is going to be 80. And here we go, selector. So this is how the service knows which pods to route to. You tell it the project is K8 intro. The magic isn't the actual value here. Again, could be John Jacob Jingleheimer Schmidt for all that Kubernetes cares. The only thing that matters is the project you configure here matches the name of the thing you put here. That's what ties those two things together. So cool. And remember, this is running on the same node. You could have other services routing to different nodes. You could have multiple services running into the same node, however you want to set that up. But this is the magic right here. These projects just have to line up. So I think we're good on that. I don't think we have to save anything here. And so we will tell it to build our service, right? And again, we can use kubectl get service. Uh, great. We have Hello Minikube and Kubernetes. Great. Those are like your background services there. So we can use kubectl apply. I love the syntax on this. It's just like everything is apply and it figures out what it is when you in the configuration file, right? So we tell it the file name dash whoops dash f service local.yaml. I'm calling this one service local.yaml because some of our next episodes are going to be putting this into Azure and putting it into AWS, and we will call those like probably service dash Azure and service dash AWS, so that again, we are simple men and we name things for what they are. So cool. Service is created. We can tell it to kubectl get service, and now we have our API local. Ostensibly at this point, hypothetically speaking, we should be able to open a browser as soon as we get our browser window and go to localhost, localhost, JoeG. What do we call that? 32767, I think is what we did. Slash contacts, spell it correctly. And we should be able to reach our API, except I may already know the answer to this. Problem loading the page. Okay, can't establish a connection. So this is a known thing. And the way this gets fixed, first of all, let's look at the logs here. Where's my cursor? Come here, come here, come here. There it is. We can do kubectl logs. This is a horrible way to look at logs, but I don't have an open telemetry universal collector and like Splunk or Datadog or anything running on my local machine. So I'm just going to have to print these out on the terminal. API dash, whoops. What was it? Contacts API dash pot, right? Okay. So these are the logs. Nothing got routed there. No surprise. What happens is on Windows hosts, especially, uh, things, too many things listening is basically what it comes down to. So the way to work around this is set up a reverse proxy for the thing that you just published. And so we have Minikube. The way you do that is with Minikube service, and you give it the service name. In this case, it's API local, right? And you say dash dash URL. And what that does is that it sets up a reverse proxy to that service through to your uh, pod. Okay. You also have to leave the Docker driver. You got to leave this terminal window open. So I got to flip over to a new one in a moment, but you can control click that and you get nothing. But that's okay. Why is that okay? Because it's not an error. It's a different thing. So we resolved the last problem. And once again, we are at the stage of debugging the thing we're trying to do to debug the thing we want to do. Let's open up a new terminal window so that way that can stay there. And let's check the logs here. Now, before when we checked the logs, remember, there was nothing really going on. Like there's just some info like, okay, the thing started up, big deal. This time, we got a warning. Failed to determine the HTTPS port for redirect. Okay, interesting. That's different. And that's okay. So this is exactly where I was when it was time to go do school stuff. I think what we can do then is come back to our API. And no, not that, not the API. Let's go into here. Remember, I changed this on the pod from container port to 80 to 443. Let's see what happens now. What we'll have to do is we do cube cuddle, right? Apply dash file name pod.yml. All right. Doop, 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 doop. Sorry. Build it first. Build it and publish it. Getting too far ahead. Here we go. Docker build. We'll call this 2.1. All right. That'll work here. Now, what we should see is a lot of layers. The system cannot find the file specified. Ah, because I'm in the wrong folder. Right. There we go. Now, we should see a lot of the layers when we push this being the same. This is going to take just a moment to rebuild. And again, the two-step build. This is good. Progress is being made. We are overcoming failure by failure. It took me a while to learn about that reverse proxy thing. Again, that came from a Stack Overflow answer. So thank you to everyone who answers questions on Stack Overflow. You've been extremely useful for us over the past couple of weeks. And from the bottom of our hope, we hope we can help you one day in the same way you've helped us. And we're getting here. Usually there's witty banter between your co-hosts, but I'm the only co-host, so I have to witty banter with myself, which makes me look like a crazy person. Once again, time is flying by, and that's okay. It is fun to do what we're doing. Plenty of time here, though, to walk out, get a coffee, sip of water. I'm running on a laptop also, which is it's a pretty powerful laptop, but still can't quite beat the unyielding power of a totally filled up desktop like Joe uses. His stuff builds a lot quicker. That's okay. I can work from the coffee shop. He can't. I can also work from the treehouse. He can't. And not just because he doesn't have a treehouse. All right, cool. So that was we've built that, and so now we can push it. All right. Let me get the full context up here. Docker image push. All right. Dudley. Right. Contacts API 2.1. All right. There we go. Got it. Okay, layer already exists all in a lot of those. Interesting. Should have seen one different. All right, well, let's see how this works out. Great. Let's do cube cuddle by file name pod.yml. This should rebuild our pod. Oh, what happened? Interesting. Pod updates may not change field other than dot 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 dot. Only addition to existing. Okay. So we might have to delete that pod. With kubectl delete. All right. Delete pod contacts API. All right. Now let's see if we can apply it. Cool. All right. Good to know. When you change ports, you got to delete one and put it back through. Cool. Now, I wonder if we have to rebuild the we got stuff going on. I wonder if we have to rebuild the service or not. Well, we'll find out. Let's go to here. Boy, I got a lot of browser windows open. Here it is. And let's see here. Oh, something, a lot of nothing. All right, let's see if we can interrogate those logs here and see what happened. Nope, still. What we're looking for is a request to come in on that pod, and it doesn't seem to be getting routed through. So that's bad because that was happening earlier today, and we got a totally different error. So, all right. Let's see what's going on here. But the interesting part is it's still complaining about the SSL, even though we took all of that out. So I get to make some of my famous debugging faces as I sit here and look at things. API. Right, nope, not what we need. Docker file, all right. Expose 443, not there. Okay. Yeah. So that's been turned off. App settings. All right. JSON, right? All right. Nothing new there. And that's all there. So glorious. Oh. 2.1. There's part of the problem. Ha! Got to remember to change this when you iterate on your stuff. So let's delete the pod. And let's apply the pod. Okay. And now let's see if we can reach that port and what may happen. Nothing happening. Okay, that's all right. Let's see if we're getting any logs now. Nope, still nothing. Okay. Still complaining about the HTTPS, even though this is the exact setup I was using earlier. You know what? We're going to do something here. We are going to delete the pod, and we're going to build this from the 1.0 that I was running earlier. Okay. And now, oops, that may have been part of it also. Ooh, 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 something's happening. Nothing, excuse me, nothing's happening. Okay, let's see if we get a log file this time. We do. Yes, that's very good. Okay. Progress has been made in a negative direction, but that's all right. We can read this. And so this is exactly where I was earlier. An unhandled exception was thrown by an application. No such table as contact. So this is great. What this means is the request from my browser using that reverse proxy through the service hit the pod. The API was fired up and said, okay, there's no such table as contacts. That's weird because, as we know, there is a contacts table in that database, unless the possibility exists the code can't find the database. Um, SQLite has an interesting little feature where when you try to read from a database, if it doesn't exist, it'll create a temporary copy. So it won't say like SQL Server will like, hey, fool, you don't have this database. Um, it will create an in-memory temporary, not in memory, but a temporary database with the name of the one, the database that you tried to access. If you don't change anything, uh, when the connection terminates, it'll get rid of that database. It's transient. You have to do some data manipulation or create some tables or something in order to get that database to stay. It's kind of cool. And that's what I am suspecting is happening here is since there's getting an error, no such table content tax. It's not complaining about the database not existing, the connection not happening, or anything else. It's like it spun up a blank database. And it's like, hey, there's no table in here, obviously, because you just spun it up out of nothing. So this is excellent. I'm very excited about this because that means that everything is working to this point, and I've lost my mouse cursor again. There we go. And got to figure. I got to go watch the Hanselman thing about being the big cursor gang. So there is something we can do to look at this, and the easiest way to tell whether or not the database file is there is by uh, going to, getting a directory listing of the pod. And the way we do that is our favorite kubectl, and we tell it to execute from standard input. If you're a C programmer, you'll remember standard in, TTY, contacts API, dash pod, dash dash slash bin slash bash. So what this is saying is connect to the contacts API pod and execute a bash command prompt. Execute bash. Here we are. We are actually now, thanks to the magic of some SSH and other things, we're now actually terminaled into um, our pod, which is great. Um, we can now list the files and we can look around, and what we're looking for is contact.db, right? Because that's the database that the API uses. And oh, yeah, don't display it for sure. But there it is in our project. If we go to the Docker, um, we can start this really quickly. This may be a tragic error. We can go to our Docker container and say, all right, does this file exist on our Docker container? And if we open enough folders and look around, we can find, I think I saw it, contacts.db. So interestingly, the files in our Docker container, great. But if you notice, this is a new suspicion that I have here. It's not in our debug bin. Debug net 7, our target bin, it's not in here. And so that leads me to think that maybe it's not getting copied. So let's list the files here and look, confirmed. It's not here. And so I wonder, interestingly, although it was not in the direct output folder on our Docker container, the driver was still able to find it. But let's go up one level and see what we can see. Nothing. So interesting. Which leads me to think, okay, probably what we need to do, gosh, I can't tell you how many times I used to forget to do this. Change the properties that the build action is, uh, they've added a few. Copy to output directory. We can say copy if newer. All right, cool. So there's no build action. We want to copy that to the output directory. Now, let's save all of this. And let's go back to our terminal. Oh, we need to get out of here. Interesting. So we might be getting one step closer. Um, let's rebuild our container, right? And we do that with the Docker image build. I still don't have all these commands memorized. Hang on. Gotta copy this. We're going to name this 3.0. All right. Cool. Stuff's happening. Rebuilding. While that's rebuilding, we're going to change our pod YAML to use 3.0, right? Yeah. And let's do a nope, not changing. Nope, 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 nope. Resist temptation to change two things. Resist temptation to change two things. Right? Do we put a blank line at the end of the YAML? Yeah, we do. Okay. Resist temptation to change two things. So we're back. We're building. When we finally get this done, there's going to be a lot of cleanup. And of course, we're rolling in. There's 9 minutes left. We don't practice ending on cliffhangers of is this going to work or not. We sure seem to. We sure seem to get close on some of this. So we will get one run in, and then we may have to pick up next Tuesday. Slowly building this. Slowly building this. I don't know if anybody's been putting comments up or not. I don't see any. Um, it might just be me being a noob with this software too. Yeah, I gotta fix this. We're spending 2 minutes on a build. Got a lot of junk running though. Getting there, getting there. One thing I am gonna stop is I'm gonna stop the dashboard. I don't think I need that. Closing in on it. Projects are up to date for restore. Yes, they are. The magic of post-production will probably cut out this build. It's taking a while though, so that who knows? Might be good. Now, when I publish this, we should see uh, some new layers this time. Not all of them, but a few of them. That would be good. Okay, cool. Exporting the layers, right? So now we can do Docker. Oops. Docker image push. All right, RJW dash contacts API 3.0, right? And we'll push this up. Layer already exists. Ah, look at this. Most of those exist, so it didn't need to repush those, doesn't need to do anything with that, but it looks like it's detected that we've changed one, which we have. That's great. Okay, so it only had to change one layer. That's the application code layer. So cool, cool, cool. Very efficient with time, very efficient with space. I appreciate that a lot. All right, let's do kubectl delete pod contacts API pod, right? Want to get rid of that. And now we want to do kubectl apply. File is pod.yaml. And one last check here. We did indeed change that to 3.0, and we resisted temptation from changing anything else. Let's go here. Okay, contacts API created. Rock on. Now, in theory, I should be able to control F5 this. Problem loading the page. All right, no worries. We'll just cancel that. Cancel that. I got enough browser window open anyway. And we'll just come back here. All right, and let's drag it down. Okay. One of the many moments of truth that we've had here. And if we see JSON show up, no JSON showing up. Okay. That's sad. Nothing? Nothing at all? Totally blank? Reload it? Listen. Okay. Well, let's see if we can read a log file here. Okay. Let's see. No such table as contacts. Interesting. Let's see what we got here. Let's see if we can get here and ls, and do we see the contacts.db anywhere? There it is. Right there. All right. All right, all right, all right. That's good. Well, at least this time it has the database. No such table. Well, let's take a look at our connection string in the API, which should be here. Data source equals contacts.db. Well, that's good. Should be finding it right away. Hmm. Hmm. Well, it's like we've got a new mystery. But hey, progress was made. We've got it built, deployed to a pod, deployed a service, running it. Let's check everything. Let's see here. And we're routing through a proxy. We are routing traffic to our pod. Let's just make sure everything is green here. Excellent. Pods are running. Replica sets we haven't messed with. So that's all good. Contacts API 2 minutes ago. Yep, indeedy. That's great. So the services that are running, there's our API local. And put a label on there, node port. So very cool. And it's nice to know that you can swap out the containers. That works exactly like it should um, for CI/CD types purposes. So that's great. We've got our service running. We're routing traffic through to the pod. The pod is having trouble querying the database. That's a whole new problem, but we've made a tremendous amount of progress, I feel like, today. So hopefully we'll be able to come back on Tuesday, having resolved this crazy issue with the table not being found despite the database being there. It's a good start, though. I'm feeling better about this. So, all right, everyone, we are at the almost at the time. So I'll say have a great long weekend here in the United States. Monday's a holiday for us, except for those of us trying to debug programs or projects for a live stream. Everyone else, enjoy your Labor Day weekend. It's the unofficial, official end of summer. So if your kids aren't back in school, they sure will be soon. Thanks for tuning in, and I look forward to seeing you all again soon.